So today we're going to finish 2.5. Yesterday we did the first half of 2.5. We did problems 1 and 2. Today we're going to do problem 3 and then some practice, and then you're going to get a chance to work on your homework in class also. So have your books open to page 131. Just like yesterday, I'm going to do a problem that's not in your book, and then I will do another problem, the one that is in your book, and then you will do the next two on your own. So let's look at this problem 3. Write a function rule for the area of a rectangle whose length is 5 feet more than its width. What is the area of the rectangle when its width is 9 feet? So we're going to need to write a function rule for that. Before we can even start, we need to figure out how to find the area of a rectangle. The formula for area of a rectangle: area equals length times width. So make sure when you're doing these problems you give me what the original formula is. And then they tell us that the length is 5 feet more than its width. So that's going to be 5 plus W. So what we're going to do from here is I have area as length times width. I know that the width is going to be 5 plus W. So I'm going to substitute 5 plus W in for the length in my original area problem. So that's going to be area equals length, which we know is 5 plus W, times the width. And then we want to simplify that. So to simplify this, we distribute W into the parentheses, and that gives us an equation of A equals 5W plus W times W is W squared. And that's our equation. So we take an equation or formula that we already know, we plug in what's given to us, and then we simplify. So then to find the area of the rectangle when the width is 9 feet, we plug in 9 for W. So that gives me A equals 5 times 9 plus 9 squared. So area equals 5 times 9 is 45, plus 9 squared is 81. So the area equals 126. Now that's in feet, and with area we are always looking at feet squared. So make sure you put the correct units up there. So the area is 126 feet squared. So let's look at the problem 3 in your book. So everyone should be on page 131. And we're going to look at problem number 3.
Joyce Morris, please call 74078. Joyce Morris, please call 74078.
So problem 3 says to write a function rule for the area of a triangle whose height is 4 inches more than twice the length of its base. What is the area of the triangle when the length of the base is 16 inches? So first we need to write down what the formula for area of a triangle is. So what do we already know about area of a triangle? We know that the area equals half times base times height. And then they tell us that the height is, so the height is equal to 4 inches more, so 4 plus, twice the length of the base, so 2b. So let's plug that in to actually simplify. So that's going to be area equals half times the base times the height, which is this thing right here, 4 plus 2b. So then we're going to distribute into the parentheses. So we get area equals 1/2 times 4, so that's going to be 4 over 2b plus 2 over 2 b times b is b squared. So what I did was I multiplied 1/2 by the numbers, and then I multiplied the b's. So when we simplify, that gives me area equals 2b plus 1b squared. So then we want to plug in for when the base is 16 inches. So that's going to be area equals 2 times 16 plus 16 squared. 2 times 16 is 32. 16 squared is 256. So my area comes out to 288. This one is in inches, and since it's area, it's inches squared. We're not going to do part B where it asks us to graph it because we've graphed a lot of these. We know that this one is going to end up being a quadratic because the equation has a b squared in it. So we know it's a quadratic, so we're not going to end up graphing this one. But what I do want you guys to do is do number 5, and then on the next page do number 6 as well. So you will need to pause the video while everyone is working on that, and then we will go over the answers. So number 5 was almost exactly like the previous problem. It wanted us to write a function rule for the area of a triangle with base 3 centimeters greater than 5 times the height, and then wanted us to find the base of the height area of the triangle when the height was 6 centimeters. So the formula for area of a triangle is area equals half times base times height. And then my base is going to be 3 centimeters greater than 5 times the height. So 3 plus 5h. So I took that base and I plugged it into the equation. And that gives me a equals 1/2 times 3 plus 5h times h. So I distributed h into the parentheses. That gave me 1/2 times 3h plus 5h squared. And then I distributed the 1/2, but I could not simplify, so I just left it as area equals 3 over 2h plus 5 over 2h squared. So then when we plug in 6 for h, that gives us 3 over 2 times 6 plus 5 over 2 times 6 squared. 6 squared is 36. So when I multiplied everything, I got 18 over 2 plus 36 times 5 is 180 over 2. That's 9 plus 90, so that gave us an area of 99, and then our units are centimeters squared. So if you did not get this, or you got stuck, or you missed it, make sure that you put the correct work in your book now. And let's correct number 6. Number 6 wants us to write a function rule for the volume of the cylinder shown at right, and they give you the formula for volume of a cylinder, with a height 3 inches more than 4 times the radius of the cylinder's base. What is the volume of the cylinder when it has a radius of 2 inches? So I rewrote the volume of a cylinder. Volume is pi r squared h, and then they told us that the height is 3 inches more than 4 times the radius. So that's h equals 3 plus 4r. So I just plugged in that for h, and that gives me v equals pi r squared times 3 plus 4r. Now distributing all of that into the parentheses isn't really going to help me much, so I just left everything out. So it is okay if it makes it more complicated to just leave everything out and not distribute. So then all I did was I plugged in 2 for r. So that gave me v equals pi times 2 squared times 3 plus 4 times 2. V equals 2 squared is 4, so 4 pi times 3 plus 8. And order of operations says we do the 3 plus 8 first. So v equals 4 pi times 11, which gives us 44 pi. The units are in inches, and since this is volume, it's inches cubed. Now, because the instructions did not tell you to plug in 3.14 for pi, you just leave pi written as its Greek symbol, and we know that that stands for about 3.14, but you leave it on the outside. So you guys only have 3 problems tonight, number 10, 15, and 16, so get working on those. You should have the whole thing done by the end of the period.